so this is going to be Objective 23. We are going to solve multi-step equations. How many of you, when you get in an equation, you might know the first step to take, but then you're like, I don't know what to do from here. Have you ever gotten that way? Or you look at a problem, you don't even know where to begin. Has that ever happened? Yes. So here's what I'm going to do for you. I'm going to give you a list of steps to solve. This is a sure way list to get the correct answer. Okay? If you will follow these steps, and so this is very important that you get these steps down so that you can go step 1, step 2, step 3, step 4, step 5. You can solve any equation that I throw at you. Okay? Step 1 is parentheses. What do I mean when I say parentheses? I agree. Most of the time we say let's do what's inside of it. I'm going to tell you that we're not going to be able to do what's inside of it. So what's our next thing? If I can't do what's inside the parentheses, so what does that mean? Looking for a keyword being, say it louder, Colby, distribute. That's what I'm going to want you to do. Okay? I want you to distribute the number on the outside to everything on the inside. What will happen when you distribute? What will happen to the parentheses? They'll go away. We'll get rid of them. Okay, so we'll get rid of our parentheses by distributing. Step 2, fractions. What do I mean by fractions? If we have fractions, get rid of them. How? By multiplying by the denominator. Okay? Any questions on that? So step 1, if you have parentheses, you are going to distribute. Step 2, you're going to get rid of your fractions. You're going to multiply by the denominator. Step 3, you're going to combine like terms, and I'm going to add to it on your separate sides. On the separate sides. Remember yesterday how we talked about you need to keep your sides separate, your left side and your right side? So step 3, I'm not talking about combine everything that matches. I'm talking about on the left side, can you combine anything that matches? Okay? On the right side, can you combine anything that matches? Okay? On your separate sides. Step 4. I know yesterday that we said that we're going to work backwards from PEMDAS, and we're going to add or subtract, and then we're going to multiply or divide. Okay? But I'm going to advance you a little bit today, and I'm going to talk about it a little bit differently. Okay? And I think you're ready for it. We're going to say at this point in time that you're going to move your variables to one side, and you're going to put your numbers on the other side. Okay? And then by the time you get down to step 5, it's just a one step, so you just finish it with whatever needs to be done. You just solve it. Okay? You're down to a one step at that point in time. Any questions on your steps to solve? Make sure you know these, because again, you can solve any equations if you follow these steps. Now, I had someone earlier today who did all the steps, but did them in the order that they wanted to do them in. Do you think they came out with the right answer or the wrong answer? The wrong answer. You've got to go in this order if you want this list to help you. Okay? You've got to go in this order. So, I will tell you that this is a problem that you can solve right now. Okay? This is one like we looked at yesterday. But what I'm going to use it for is I'm going to use it, A, to remind you of what we're doing, and B, I'm going to use it to show you how we're going the new way to write. Okay? So, step 1, parentheses. Do you have any? No. And if you don't have any, you can skip it. I like this one already, right? Skip that step. Step 2, fractions. Yes. Let's multiply by a common denominator, which is 4. Very good. So I'm going to times everything by 4. When I times 5 halves by 4, what do I get? -10. Very good. Any questions on how to get that? 4 times parentheses, -5 divided by 2, close parentheses. Okay, if you're doing it by hand, it's 4 over 1 times 5 over 2, or -5 over 2. The 4 becomes a 2. The 2 becomes a 1. 2 times -5 is -10. Any questions on that? Okay. 4 times 3/4 x is 3x. And 4 times a half of 4 is 2. Okay. Now, I do realize that you are at a 2-step. And you could do it like you did yesterday. But I'm going to show you a new way to write it today. Okay. So, the new way to write it is this. Step 3, combine like terms. Anything to combine on this side? No. Anything to combine on that side? Anything match? No, they don't match. Okay, you with me? If you had a 3x and a 2x, you could combine them and make 5x, okay, if they matched. But if they don't match, you're just going to leave them. Okay, so skip step 3. Step 4, put your variables on one side, put your numbers on the other. Okay, everybody look at what we have. We have a -10. We have a variable, a 3x, and we have a number, a 2. If my variable is here, where do I want all my numbers? Over here. So which variable, or which number, do I need to move over here? Now, normally, how would we move a +2? Normally, we would subtract 2 here and subtract 2 here. Watch this. New way to write it. I need to move this guy over here. And this is like a magic mirror. When he crosses the equals, he now becomes a -2. And I bring down my 3x. And then I can combine these because they match and make -12. And then from there, you can just solve it and divide by 3. Okay? Don't pass judgment yet. X is equal to -4. Any questions on how to check? Do I need to show you how to plug this in? I do want you to check. I do want you to continue that, but for time purposes, let me know which ones. If you're okay with this, I'm going to keep going. If you need to see it, let me know. Everybody okay? Okay. And ask me later. I'll ask you, do you want to see the check? Do you not want to see the check? Okay? So, stay with me on this. Step 1, parentheses. Yay or nay? No, skip it. Step 2, fractions. Skip it. Step 3, combine like terms on the separate sides. Can you combine anything on this side? No, they don't match. Can you combine anything on this side? No. So go to step 4. We like this one. Skip 1, skip 2, skip 3. We're almost done. We're at 4. Okay? Step 4. Here's where I say put your numbers on one side, put your variables on the other. I like to use a pen and pencil trick. Can I borrow a pencil, please? Can I borrow a pencil? Got a bright colored pencil. Okay. On one side of my equation, I have a number and a variable, a pen and a pencil, two things that do not match. Everybody see? On the other side of my equation, I have a number and a variable, two things that do not match. Do you understand? My goal is to get my numbers on one side and my variables on the other. My thought is, does it matter which of these pieces? If I want to put my pens on one side and my pencils on the other, does it matter what I pick to move? No. So, Allison, pick something to move. I want to get my pens on one side and my pencils on the other. So move the blue pen over here, and then that means you move the blue pencil over here. Got pens on one side, pencils on the other. Do you understand what I'm saying? Okay. What if Logan didn't want to move? Which one did you move? The blue pen. What if you didn't want to move the blue pen? She wants to move the blue pen first. What if you want to move something else? Pick something different. So he says, I want to move the red pen over here, which would then mean you move the pink pencil over there. Did it matter? You still get your goal achieved. Pencils on one side, pens on the other. Okay? Grace, pick something different than the blue pen or which one? The red pen. What if you didn't want to move a pen first? What if you want to move a pencil? Pick one. She says, let's move the pencil first. Then you would move the pen over there. The point is, all of that stuff, it does not matter which one you pick to move first. Okay? We see that the 2 is going to match with the the 6. And so either I need to take the 2 over here, or I need to take the negative 6 over there. And we see that the 5K matches with the 3K. So either I need to take the 5K over here, or I need to take the 3K over there. It does not matter. Okay? I do have a preference, though. Okay? Ready for the easy button? I do have a preference. Do we agree with problems are easier when our variable is positive? Yes. Because when your variable is positive, you don't have to worry about your signs. You follow? You don't have to worry about forgetting to drop your signs, and less careless errors occur. So here's the thought. If you can, move the smallest variable or the one that is negative. Why would I move a negative one? Because when I move it, it changes to positive, right? So I would move my smallest variable. So what would I pick to move? I'm going to start by moving the 3K. Now, it's a positive 3K, so I'm going to pick him up and move him over here, okay? When I do, what happens to him? He becomes a negative. As it crosses the equals, he does change signs, okay? So I'm going to scoot this stuff over. And I told you the other day, it's important that when you move things over that you always put what you're doing at the end. So minus 3K on this side. What's left on this side? Okay, now let's combine what matches. 5K minus 3K is 2K. All right, so take a look. My variable is over here. So what does that mean? I want my numbers over this way. So what number do I need to pull over here? I need to move the 2. It's a positive 2, so as it moves over, it becomes a negative 2. So 2K is equal to negative 8. And from there, divide both sides by 2. Okay? I got my variables on one side. Everybody see that? I got my numbers on the other side. That was the goal for number 4. And then number 5 is just solve. So K is equal to negative 4. Any questions on that? Harvey? Like if you wanted to move, like could you move the 2 first? Yeah. Remember I said pens and pencils. Allison did it one way. Logan did it another way. Grace did it another way. It's fine. I focus on keeping my variable positive because it's easier when it's positive. So I always move my smallest variable first. Okay? So, yeah. It would. If you moved the 5K over this way, it would be minus 5K. Okay? So option 2, if you solved it a different way, just to show you. Okay, pick something different. I moved the 3K first, so Austin says, let's move the 5K over. What happens to it when it moves over? It becomes a negative, so what is left on this side? 2. 3K and negative 5K gives me a negative 2K. And then if my variable's over here, I want my numbers over there, so what would I move? The negative 6, and it would become a positive 6. And so I would get 8 equals negative 2K. And then when I divide by negative 2 on both sides, K would be equal to negative 4. Still the same thing. I like for my variable to stay positive. So that's why I moved the smallest. I would not recommend, you could, and I have people that insist on doing that. But I also find that what happens when they do both at the same time. When they go, hooah, and they throw too many things over at one time, careless errors occur. So if it were me, I'd move one thing over at a time, put what you get when you combine them, then reevaluate and say, okay, now what do I need to move? Move that thing over this way, combine them. That way you're not making careless errors. You can, though. I mean, you can. This over here, and it works. But I don't recommend it. Okay? How do we feel about throwing it over? How many are okay with it? Got 1 or 2. How many still are like, I don't know. It's kind of weird. Okay, stick with me. It will get better, I promise. Do you understand the concept of it, that it's the same thing? I'm just not writing. Like when I throw it over a positive 2, yesterday I put minus 2 over here and minus 2 over here. All I'm doing is now I'm picking up and I'm still minusing 2 when it comes over. I'm just not writing it over on this side. Okay? All right. Step 1, parentheses. Skip it. Step 2, fractions. Yes, what would I times by? 4. So I want you to take a minute. How many terms do I have up here? How many things am I going to times to? I got 4 terms, so I need to times to all of them. So take a minute. All I want you to do is times 4 to every single term up here. And my question is this. How many of you are putting it into the calculator? What am I going to put in right here into the calculator? Everybody says, I'm going to put in x over 2. No, you can't put in the x. It won't work. I'm going to put in 1 over 2. You with me? That's a 1/2. Okay? So 1 divided by 2, and I'm just going to drop the x. So take a minute, put what you get once you times everything, and just stop. Stop at that step. All right, let's see how far we got. And if you can get to this step, great. Okay? Remember how you kind of felt uncomfortable with fractions the other day? How many of you are starting to feel pretty good about those? Okay? It'll get better, I promise. So you should be pretty comfortable with this by now. When I times this by 4, what do I get? 2x. When I times this by 4, I get 4. When I times this by 4, I get just x, because the 4's become 1s, right? And when I times this by 4, I get negative 24. Okay. Step 3. Combine anything here? Anything match on this side? Nope. Combine anything here? No. If you could, you would, but we can't, so we're not. Okay, why do I keep asking if you can combine? Because eventually, there'll be something you can combine. Okay? Step 4. Put your variables on one side, put your numbers on the other. What would I pick to move? The x. The positive 1x. And so when I move it over, what happens to it? See, normally, guys, what would cancel with a positive 1x? So normally I would subtract 1x here. When I move it over, I'm still subtracting 1x here. I'm just not putting the minus 1x over here. You with me? I'm just not writing it. And I'm not doing that part. And so this comes down as a negative 24. I'm going to combine what matches. 2x minus 1x is 1x. And then, if my variable's on this side, what do I need to move over there? I want my my variables on this side, so I want my numbers over yonder. So I'm going to pick the 4 up. When I move it, it becomes negative 4. So x is equal to negative 28. Okay. Here's my question to you. How many are interested in how to do the check on this? I got 2 variables. You do realize these are different because yesterday I only had 1 variable. Today I got 2, and not only do I have 2, I got 1 on the left side and 1 on the right side. So I got to figure out what to do with them. The question is, where do I plug the negative 28 in? For both of them, right? So I'm going to put negative 28 over 2 here, plus 1, equals 1/4 times negative 28 minus 6. Okay? Yesterday when we first started, I said, how do you check? They said, well, you plug it in. I said, what do you mean you plug it in? They said, you work it out. And I said, what do you mean you work it out? They said, you work the whole thing out. Would you agree with that statement or disagree? You work the whole thing out. I don't think you work the whole thing out. You work both sides. We work the left side. We work the right side. And then at the end of the day, the two sides should equal. Okay? So, divide first. Negative 28 divided by 2 is negative 14 plus 1, which is negative 13. So I work that side out. On this side, what is 1/4 times negative 28? Negative 7, and negative 7 minus 6 is negative 13. Any questions on that? You plug it in, you work the left side, you work the right side. At the end of the day, the two sides should match. Okay? And so that does work. Check, check. And if it doesn't match, you've obviously done something wrong. Okay? How about, I'm going to let you try this one. I'm going to talk you through it to begin with, and then I'm going to let you try it on your own. So everybody put your pencils down for 2 seconds. Let's just look at it. Okay? The best thing to do on a problem is never to just start writing. Right? You need to look at it and see what you got. So let's get a game plan. What's my first step? Parentheses. What do I mean by parentheses? I'm going to distribute. I'm going to distribute 6 to the 5m and 6 to the negative 3. Do I do 6 to anything else? No, because it's just that set of parentheses. Okay, then I'm going to do 1/3 to the 24m. And then 1/3 to the 12. Everybody says, I can't do that. Yes, you can. You got a calculator. Parentheses 1 divided by 3, close parentheses, times 24. Okay? So, distribute first. Then if you still have fractions, you'll take care of your fractions. Then from there, you'll combine like terms if you can. Then from there, you'll start moving stuff, pens and pencils. Put your variables on one side, put your numbers on the other. See how far you can get with it, okay? And again, we learn by making mistakes. So if you didn't get there, or if you only got part of the way there, that's okay, because the goal is get as far as you can and then figure out where you went wrong. And then on the next one we do, get further. You with me? That's your goal. And keep learning. So here we go. Step 1, parentheses. I mean distribute. So I'm going to take the 6. 6 times 5m is 30m. And 6 times negative 3 is negative 18. Do not be scared of this. Everybody's like, oh my gosh, fractions, parentheses. And some people want to take this thing and times by 3 to begin with because they see the 1/3. Why would you not times by 3 to begin with? Yeah, it's outside the parentheses. And the other thing is what? What comes first in your steps? We always say, ooh, yuck, gross, disgusting, nasty, get rid of them fractions. But then we always say, you know, get rid of them parentheses. Always do parentheses first. So which one comes first? Parentheses trumps fractions. You with me? Parentheses is always your number 1. So before I take care of my fraction, I'm going to go ahead and distribute this guy. Then if I still have fractions, I'll take care of the fractions next. Do you understand? So 1/3 times 24 is 8m. Ooh, look what happened to my fraction. It went away. 1/3 times 12 is 4. So here's my thought. It's not as scary as it originally looked. Okay, we distributed. My fractions went poof. They went away. Okay, so step 1, parentheses, check, check. Step 2, fractions. Do you have it anymore? No, no fractions. Step 3, combine like terms. Anything match on this side? No. Anything match on this side? No. Skip it. Step 4, put your variables on one side, put your numbers on the other. What would I pick to move? I would pick my smallest variable. When you move it over, what happens to it? Negative 8m. It turns to a negative. So combine what matches. The 30m and the negative 8m are going to make 22m. And I just bring down the negative 18. So far, so good. From here, Jordan, if my 22m is on this side, where do I want my numbers? On the other side, so what do I need to move? The negative 18. Very good. How many of you are circling with me If you're not circling and you're not drawing a line, you see what I'm saying? Just by me putting a line on the piece of paper, it's like I'm telling myself, deposit that negative 18 here. And it becomes a positive 18. So 22m is going to equal 22. Well, I'm not done yet. I did. Everybody agree? I got my variables on one side. I got my numbers on the other. Okay. At this point in time, step 5, what's left to solve? What's with the m? Timesing by 22. So to get rid of it, we will divide by 22. And everybody says, these cancel, so you just got nothing. Well, you got something. 1. 22 divided by 22 is equal to 1. Okay? And then I had some people say, I got the answer, Miss Corns. I don't know how to check it. So just to make sure, we're going to put the 1 there, and we're going to put the 1 here. So check this out. 6 times 5 times 1 minus 3. So far, so good. Equals 1/3 times 24 times 1 plus 12. Now, there's no mystery anymore. So we're back to PEMDAS. Okay? What do I do first in PEMDAS? I'm going to do parentheses. So 5 times 1 is 5. And 5 minus 3 is 2. And then I'm going to times and get 12. Any questions on PEMDAS? Over here, what do I do first? I'm going to do inside the parentheses. So I'm going to do 24 times 1, which is 24. And then 24 plus 12 is 36 when you add them. And 1/3 of 36 is 12. Yes, sir. Now, when we get to the quadratic equations. But right now, we are solving linear equations in one variable. Like, your variable is the same variable, okay? So, no, not in this class. You won't have, like, x squared, x cubed, x. We will have quadratics, x squared, but that's a whole other chapter. So, not in this chapter. How about that? Okay, any other questions? How many are starting to be better and okay with the throwing? Circle and throwing it over, is it getting any better? A little bit better? How many like it better than and how many still like the old way better? And that's okay, but again, trust me, this time next week, you're not going to want to do the old way. You're going to want to do this way, so it will get better. Okay? So, write this one down, and then let's talk about it before I let you go with it. What comes first? Parentheses. I'm not going to times by 15 and get rid of those fractions. When do I do that? Next. Okay, do your parentheses first. Tell me this. Somebody in their calculator, do 1/3 times 2 and tell me what you get. You get 0.6 repeating every 6 minutes. I get a decimal. What do you do with it? Math, enter. Make it back into a fraction. What should it be? 2/3, okay? So do 1/3 times 2, 1/3 times negative 12. Don't forget to drop your m's. You follow? Step 2, get rid of your fractions. You got denominators of 5 and 3. What are you going to times by? You got denominators of 5 and 3. What are you going to times by? 15. So times everything by 15, and then see if you can finish solving it. All right, what did we come up with for our answer? How many got 15? Okay, a lot of us. If you didn't, follow along. So this guy I'm going to just leave. Parentheses comes first. 1/3 times 2, you do get 0.6 repeating, but you go math, enter. And everybody said, so you mean you still have a fraction? And I'm going to drop this m down. And I said, yes, I still have a fraction. And they're like, oh, but that's okay, because in a minute, we know how to get rid of fractions, so we'll do that in a minute. Okay, one thing at a time. Sometimes when you times a fraction by a whole number like this, 1/3 times negative 12, it does get rid of the fraction. You just get a whole number, and we like it when it does that. Okay, but not always. Okay, step 2. How do I get rid of my fractions? Multiply by a common denominator. What can 3 and 5 both fit into? 15. So when I times this by 15, I end up with 6m. And everybody says, I thought they were just going to cancel and you drop the numerator. They won't completely cancel, but they will reduce, and I told you when I gave you my sales pitch the other day, I said I'm not going to completely just cancel it out, but I will be able to change it into a whole number for you. Okay? So then I times 15 here, and I get 10m, and I times 15 here, and I get negative 60. Okay? Step 3, combine anything here, combine anything there. So then I go to step 4. Put your variables on one side, put your numbers on the other. Well, look what you got. Everybody says, you move your smallest one, Miss Goins. You move the 6m. Tell me this. What, if I move the 6m over here, what would I be left with? No, I'd be left with 0, right? And I'd have all my numbers and my variables over here. My thought is this. I got a number, and a variable, and a variable. This number is already over here. What would be the smartest thing to move? The 10. And everybody says, but I thought you said the smallest, Miss Goins. I said most of the time the smallest, if you can. But do use your common sense. You know, some people, did anybody take the 6m over here and then take the negative 60 over there? And then you did like a bunch of extra steps that you didn't need to do. Okay? Is it okay that you did that? I mean, you came out with the right answer, but I'm trying to save yourself some work. Okay? How many took the 10 over? Thought to take the 10 over? Because you had your number here, so you take your 10 over there. So this becomes minus 10m. I'm left with a negative 60. When I add those, that gives me negative 4m equals negative 60, and then I divide by negative 4 on both sides. And a negative divided by a negative is a positive 15. Anybody need to see the check on this? Want to see the check? You plug it in here, you plug it in here, you just work PEMDAS. Like I would times these together first, work your numerator first, then divide. Over here you would work your parentheses first, and then times by a third. At the end of the day, the two sides should come out equal. Okay? Everybody okay? All right, last one. All on your own. Talk me through it. Where am I going to start? Okay, so 1/4 times D is 1/4 D. And then? Well, you actually have to distribute. I do agree to get rid of the parentheses, but in order to do that, you got to do 1/4 times 5 as well. You got to multiply to everything on the inside. So 1/4 times 5 is 5/4. Now what? What do I do on this side? So 1/8 times 3D. I'm going to help you out. That gives you 3/8 D. Then what? Times negative 2. Awesome. And that's going to give you negative 1/4. Is that right? Okay, now what? So where's your steps to solve? Step 1 was distribute. Take care of the parentheses. What was step 2? Fractions. So what am I going to do? Get rid of them. Awesome. So you see what I'm saying? You got to revert back to that list. So what common denominator do I have? Well, I have 4, 4, 4, and 8. What can 4 and 8 both fit into? Something larger. Which one's better? Would you rather multiply by 8 or would you rather multiply by 16? Either one would work. 8, because it's smaller, okay? But I say think the larger number because most people get confused, the factors and the multiples. Most people say, you know, what can 4 and 8, what can go into 4 and 8? And the answer is 4. But I want to know what 4 and 8 can fit into, something larger, which is 8. Okay, so when you times this by 8, you get 3D. When you times this by 8, you get negative 2. When you times this by 8, you get 2D. And when you times this by 8, you get 10. Okay, much easier now that all my fractions are gone. Step 3, combine like terms. Combine anything over here, Brandon? Combine anything over here. No. Step 4. Put your variables on one side, put your numbers on the other. What would you pick to move? Sure. And that's okay. Anybody pick anything different to move? What did you pick? The 2D. Doesn't matter. Remember, Allison and Grace and Logan, they all pick different stuff to move. It don't matter, so that's fine. You want to move this over? What happens to it? Awesome. And what am I left with over here? Equals 2D, and then you can go ahead and take these two and add them and get 12. Now what moves? The 2D. Very good. And when it moves over, it becomes negative 2D. And 3D minus 2D is 1D equals 12. Okay, and you're done. Okay, any questions on that? Can we talk about the check real quick? You got the check. Good. Okay, let's talk about the check real quick, because the check, how many got stuck in the middle of the check? Anybody get stuck in the middle of the check? How many got to the end of the check and it was weird? Okay, and so it might happen. So let's just take a look at the check real quick. And I'm going to actually erase this. So we know the answer is 12. Here's your check. 1/8 times 3 times 12 minus 2 equals 1/4 times 12 plus 5. Well, watch this. Work your parentheses first. 3 times 12 is 36. And 36 minus 2 is 34. What's 1/8 times 34? How about 17 over 2? 17 over 4? 17 over 4. Okay, I do agree. 34 over 8, but reduce 17 over 4. Then work this side, 1/4 times 17, and when you times 1/4 times 17, you get 17 over 4. So even though it does turn out weird, it doesn't matter as long as the two sides are balanced. I just wrote, that's a 17. That's a 1 and a 7. Sorry, I'm just writing fast. Are you okay? All right, so I would like for you to try this. On page 100, I want you to try 1 through 4 and 10 through 14.